We are on to the final panel of the day. And for those of you who remember your history lesson from this morning, there, as was said earlier, there is no test. But I think it's striking that back in the late 90s, early 2000s, when nanotechnology was, such a nascent field, everything that we stood up was always being directed towards this idea of commercialization. And so much in that same way, this meeting, we are leading up to the final panel, which is commercialization. And so I'd like to welcome up our commercialization panel. Is moderated by another NSET member, Jim Burgess from the Army Research Laboratory. It includes Terry Dankovich from Folia Materials, David Hatrick from Huntsman Materials. On your program, it says Rick Schneider of Google, but he, like Lamar Hill, fell ill. And so we have Dr. Matt Hull, who is the founder of NanoSafe and has agreed to take his place on the panel. So thank you very much. And Jim, it's all yours.
Well, good afternoon. Before I start, I want to thank Brandon and the NNCO team for organizing this event and also for articulating the importance of NNI. Without their work, none of this would be possible. And so the work that they do day in and day out deserves an applause. Hold your applause for now. I'm going to say more because, it's really important to have a place for all of us program managers to come and meet. And what is critical is the agenda that's set and the seriousness of purpose that's provided by Brandon and Quinn and the whole team. It really matters. We identify synergy, we find out what the pain points are, the various agencies, and we talk about solutions. And so infrastructure and workforce and commercialization and all of these things are critical, but there are people behind the scenes who are very talented at their job that deserve applause. So we appreciate the work. And so I appreciate the invitation. I was excited to moderate this panel. I'm the program manager of the Army's Institute for Soldier Nanotechnologies, and we are required by contract to focus on moving fundamental science to the commercial sector, transition it up the pipeline. It's a very difficult job, but if you look over time, and the ISN was stood up at the same time as the NNI came online, and we have incredible success stories over 20 years. And so, one way to look at the situation is to say everything happening in the academic labs is 15 years from being out on the market. But also, it's also true that everything that we have on the market was working in a lab 15 years ago. So, we can take an optimistic view of the whole pipeline. Nano is crept into all of the disciplines. So it doesn't matter what your formal education is in, you will have a lens to look at nano through that is dictated by that formal education, but it's possible to come together in the nano realm and have multidisciplinary discussions because of that. These non-native nanoscale structures that kind of bring us all together. And so it's great. And so before we start with formal questions, I'm going to ask the panelists to tell us a little bit about your background. And please start with your formal education and tell us what path led you into the nano realm, please.
All right. Should I start?
Yeah, go ahead, Terry.
All right. Hi, I'm Terry Dankovich. I have a PhD from McGill University up in Canada. And that was when I first started working in nano, which I actually got into it because of the application side. I was in materials chemistry, working with actually paper materials. And there was an application of an antimicrobial paper using nanosilver. And let's see, it's been more than 15 years. No, not since I graduated, but since I started working on the project. And now that is the initial start of our company, Folia, where Folia Materials being the parent company, Folia Water being the water filter company. So we focused on the water filter for the company. And that was kind of due to like the enormity of the water crisis in developing countries that was really focused on with the Millennium Development Goals in the early 2000s and then the Sustainable Development Goals later on. And that really drove a lot of my interest in nano as a solution for that. There's been a lot of stuff all along the way. I've done a couple of postdocs back here in the US related to like the first one at University of Virginia in the Center for Global Health, which is very different than chemistry. I decided to, instead of just continue on in chemistry, to continue on with my project, which is unusual. And that one, we went to South Africa and tested this filter paper with water in South Africa to see if it could kill bacteria down there, which no surprise it could. And then following that, I was like, well, there's all this environmental implications of nano, which I'm surprised we didn't actually talk more about today. But that was pretty definitely a big deal. This was like around 10 years ago. And so I wanted to kind of try to answer those questions again myself. So I did another postdoc under LC Nano, which was a network with, there's some Arizona State people here and Carnegie Mellon and a few other schools. But that was looking more about nanoparticles coming off of consumer products such as plastic or textiles, or at least my part of the project. And because it didn't seem to be that big of a problem, I kind of got pushed actually through more of a media news story to start a company. Like I originally wasn't sure because I'm trained as a scientist. I want to make sure I check all the boxes before I do something. Gotten past that, but essentially I wanted to know that it was going to be something not only efficacious but safe for consumers. So lo and behold, around 2016, we started Folia, and it's, you know, we've gone through like many of the things that people have talked about earlier today of figuring out how to get a lab set up, figuring out the workforce, who to hire, figuring out how to analyze our materials, and you know, we didn't have an SEM or whatever. So a lot of these things like we went through as a company as well. So I think I'll leave it at there.
You're a shining example of good nano for sure. And your education is materials and chemistry or only chemistry?
Well, materials chemistry was the subset, but it was in the chemistry department.
Right, okay. Right, David?
Yeah, good afternoon, everybody. I'm David Hatrick. So I'm a PhD physicist by training. I did a PhD in nanopolymer studies at the University of Strathclyde, Glasgow, Scotland. My first job out of grad school was in nuclear waste management, which is not the sexiest area to start your career. The reason I ended up connected to nano was my wife, as she was about to become, told me she didn't want to live near a nuclear waste facility. So we moved to Cambridge in the UK, where I joined a technology consulting firm, which helped companies figure out their technology strategy and where to make investments in R&D. And my first exposure to the world of nano was helping to write the UK National Nanotechnology Strategy at the time. I got a little bit bored with paperwork and then moved back into industry. I moved to Huntsman Advanced Materials. So Huntsman's a multinational chemistry company, specialty chemicals. The division that I'm in, the Advanced Materials Group, has got a long history in thermoset chemistry. So starting off originally with epoxy materials, but over time moving into a whole bunch of high performance resins for the aerospace industry, for an example. So if any of you had the chance to fly on a Boeing 787 or a an F-35 maybe, you're flying on our materials. It's our resins that are used to make the carbon fiber composites that make those aircraft. In about 2018, the company made a decision to acquire a startup company, Nanotechnologies. So you ask the question, why would a thermoset chemistry company be interested in buying a carbon nanomaterials business? Well, the answer is written in what your customers are looking for. So in the composites area in particular, our end customers, the OEMs that are building aircraft, had a bunch of needs around temperature, toughness, et cetera, for materials that we couldn't provide with our existing toolkit of materials. And the technology that Nanocomp had was a good match in our portfolio to fill that gap. So we bought the company in 2018, and since then we've developed a business plan which basically is in two parts. So we've got what I'd call the traditional business, high performance materials, which tend to not be high volume, but very high value. And we sell material to a variety of agencies sitting around the room at the moment. And we've been fortunate to receive funding from a lot of those agencies, which we're grateful for. That business continues. We're doing a lot of work to extend the properties of the material and reduce the cost. After about a year of owning the company, there was a study was done in parallel with DOE through the ARPA-E agency to look at what would the scale of a carbon nanotube business look like if you take into account most of the feedstocks we use are hydrocarbons. So that's why we like carbon, but quite often we're left with free hydrogen, which in the facility the size we have today goes up the chimney as waste. We can't use that amount of hydrogen. Question was, if we scale this up to be able to produce kilotons of hydrogen and kilotons of carbon nanotubes, could we create a sustainable high volume business which creates a very low carbon footprint hydrogen as either a fuel source or a chemical for consumption in various reactions driven around the world today? So a very low carbon footprint, sustainable form of hydrogen. And the idea was formed to create a second part of the business that had those two products as revenue streams. So clean hydrogen and carbon nanotubes with good structural, electrical and thermal properties that we could use at high volume and a lot of different applications. So that's where we are as a business today. We are a few weeks off starting up quite a large scale reactor, going to produce about 30 tons of nanotubes a year here in the US, based in Texas. And we're looking forward to the commercialization phase of that, finding the right markets and customers to make that business a success.
So phenomenal array of experiences for our panel. Thank you for being here. Matt?
All right. Well, first off, I appreciate being here. I thank you to Quinn and Brandon for asking me to step in. And I'm really sorry you don't get to hear from Rick. Rick and the Raxium Google story is amazing, and I would encourage you to look into that. Mine is pretty incredible too, I think, but Rick has a great story, and I hope you all get to hear it. So like much of my career, it was complete serendipity that brought me into the nano domain. My undergrad and master's degrees were in environmental science. I went to work for a company that just so happened to be commercializing a nanomaterial. They had licensed it was basically an endohedral metallofullerene from Virginia Tech, and they were going through the process of commercializing that. And on my way to the lab, I would see this arc reactor being packed with a graphite rod, and being burnt and then harvesting soot out of that reactor. The folks were wearing pollen masks and gloves with exposed skin and that sort of thing. And so I started asking questions like any good environmental scientist does. And that led me to create a program. One of the big concerns that we started having was just like Folia, are these products going to be safe, or are we doing enough? And so I created a framework called the NanoSafe framework, and this was around 2003. I think we first presented some of that work with NIOSH. And this was a way to use other people's, to be blunt, it was a way to use other people's money to help us fund safety studies in a nano manufacturing facility. So we had funding from a lot of wonderful people at that time. We've heard Chuck Geraci mentioned in the NIOSH group. We also have to mention Mark Hoover, Vladimir Murashov, who is here. I would encourage you to talk with those folks. They were doing amazing things. We brought a number of those people into the facility. We were basically getting research grants to study how to do nanotechnology safely. And so that NanoSafe framework, I started thinking, well, maybe we can commercialize this. Maybe this could, maybe we could become the underwriter's lab for nano. Maybe we could help people with test and verification. And this came after watching a number of federal folks being grilled in forums just like this in the early days of nano. I'm thinking maybe Barb Karn at EPA, Chuck also at NIOSH, number of folks from OSHA. They would get up there and speak, and the crowd could be quite probing with some of the questions. And I could always see the reluctance of the federal folks to answer some of the things because we just didn't know them. And I thought that NanoSafe or a NanoSafe tested or NanoSafe verification program could help answer some of those questions in the interim. And so founded NanoSafe at the same time that I started a PhD at Virginia Tech. So I went through this career identity crisis. Was I a technology transfer person? What was I going to be? So I started a company, started a PhD at the same time, coincidentally with Pete Pickesland, who's also here, I think, and maybe he's already headed down 81 back to Blacksburg. But Pete was a gracious mentor and advisor who allowed me to be an entrepreneurial, he had this crazy non-traditional student who had a family and had a startup company, and we worked together, for 3.5 years and successfully did the PhD and also kept going with NanoSafe. And fast forward to now, so a year ago, I actually sold NanoSafe to a company called ITA International to take it to the rest of the way. After 16 years, I had done enough. And I should also mention that I've always had one foot in academia. I really applaud the entrepreneurs who, and the nano entrepreneurs in particular, who have been able to do it without a foot somewhere else, because it's really scary when you are waiting on a grant to get awarded or some source of funding and you don't have a safety net. So I was always fortunate I was at Virginia Tech as a PhD student. Now I'm there as director, as a research professor and director of the nanoscale characterization fabrication lab there. And that's the role I've played. And I guess you asked about my degree, right? So it was a PhD in environmental engineering. So I'm an environmental scientist who got into nano, and that's the story.
That's great. Yeah. Environmental from the outset. Yeah, I caught that. And thank you. Rick fell ill at the last minute, and Matt jumped on a plane and is filling in, on short notice. So we appreciate that. And so I guess we'll get started. We've heard a lot today about how NNI has supported infrastructure, human and physical infrastructure, to advance research and development in nanotechnology. And so our first question to the panel is, what federal resources or programs have bolstered your successful commercialization of nano or nano-enabled products? We can go with Carrie first,
Okay.
since you have.
Yeah. So I was starting to think, oh, well, clearly I'll mention the NSF SBIR because we've done phase 1, phase 2, phase 2B, like all the supplements, whatever we could get out of it. That's been obviously very helpful, but we've also had some other things that are, been mentioned today. Like I used to go to the Singh Center at UPenn and do electron microscopy, and forgot the name of the grant that it was under. It was like a seed grant for small companies. And I've also worked with the Cornell Center and did something called a Jumpstart program, which was through New York State, and other schools as well. So there's been a lot of using university resources that are set up for, small companies or large companies for that matter. They just get a different rate. To come in and either use their facilities or sometimes just send samples, and a grad student or somebody at the university would do the analysis. It depends. And we've also been on kind of some supporting stuff on other grants related to a NIST grant, and probably will be on a DOE grant soon. But a lot of different federal agencies out there obviously are supporting nano.
SBIR, yeah. Okay, David.
Well, there's probably two phases here. It's about when NanoComp, as the startup company started, the management team there were pretty adept at finding SBIR and other mechanisms to fund the company to start to develop that technology. And that's continued right through until now. I think the second phase of the company, where we're talking about the higher volume and moving into mass market production for nanotubes, a lot of that has been done through internal funding. So developing business cases within the company and justifying the investment ourselves to do that. But there's always been an underpinning, let's call it technology platform development, which is the high risk side of things, which as a kind of public company, we find quite difficult to kind of fund that kind of research ourselves. So if something's not going to have a payback for 10 to 15 years, tends to be a tricky thing to try and develop in a public company with shareholders with expectations. So we've still got a strategy where it makes sense to look for federal funding to do that basic research. But certainly the measure of success of that for me is the ability to then take that and speak internally to our kind of fund holders and get the investments to take that to the next step. So there's still a kind of a strategy to use it. But as I'll kind of stress, success is when that moves forward into private funding.
Yes, and as the government, we get the knowledge gain also, whether
Yeah.
that
And
makes
certainly
it true
there's
or not.
lots of collaboration with multiple universities and federal institutes along the way. And obviously, the more funding you have available to pay for some of that support as well, the better. Because there's no way any one company can be successful here. We all have to work together. And if you can use the funding to make that happen, then all the better.
Yeah, really interesting aspect of workforce development through those grants. Matt?
Of course, I would want to cite the SBIR program. I learned to write grants on SBIR, so apologies to academic institutions if I write a SBIR sounding grant. But they really have a complicated component in there in terms of the commercialization section, and that's something that's a little challenging to master. But I had SBIR support. The first one came from EPA, Nora Savage, and again, Barb Karn were at EPA at that time. Multiple grants from the Air Force SBIR program and Sabir Hussain at Wright-Patterson Air Force Base. More recently, an NIEHS SBIR for looking at 3D printer emissions to the company. And I think they have also, since my exit, have been won a NIST SBIR. So there's a lot of SBIR support there, and it's great money for really exploring, the nascent opportunities behind the technology that you're working on. So I would say that, but I would also go back to some of there were names that I said in there along with the SBIRs that I think are really important. And Doyle touched on some of those this morning, I think, in his conversation. He mentioned that environmental lab down at Vicksburg, Mississippi, that had a lot of support, I think, that was flowing through DOD to do a lot of the environmental nano research. And so when we would get an SBIR to support something in that area, and we had this great resource there. So same is true for Sabir Hussain at Wright-Patterson. There was great support for the lab, and so there was expertise that, publications and all the great results of that lab were really huge. I would also cite an I-Corps program that I think is amazing. I did it backward. So I started the company and then did an I-Corps later and realized how badly I started a company. And I did this with Jamie Lead at the University of South Carolina. And I applaud that program and how it forces us to think about, are we solving a problem? Are we just pushing a technology for its own sake, or are we connecting to a customer need? Do we have?
Was that the commercial plan, the business plan that they helped with?
I'm sorry, with the I-Corps?
Yeah, so I'm asking, what gave you the confidence to attack a business plan and a market analysis as an academic? Because I think that blocks a lot of PIs from making that leap.
So the nice thing that I discovered about I-Corps was I didn't like the business plan. To me, a business plan is, I know exactly what I'm going to do. I'm starting a business. I'm replicating something that is pretty well known. But if I've got a new technology and I don't see a comparable business for that, how do I take that to market? And to me, the I-Corps program solved that by really focusing on business model generation. So it's not the plan as much as it is, what's the business model even going to look at? So they bring you back a step and let you get more comfortable with figuring out even what the components of a business plan would look like. So the I-Corps puts you through a lot of different steps before you have to get there. So you can be very uncomfortable with business plans, and actually you'll probably do better in I-Corps than if you know.
Right, yeah. Fantastic resource. So let's drill down a bit. How do needs differ between early stage commercial innovation and later stage scaling up of production? Is that as simple as a phase 1 versus a phase 3? I mean, let's unpack that. Terry, go ahead. Yeah.
Well, the early phase, you often have, the expenses are kind of different. Like you might spend a lot more time doing the R&D in the lab and making little samples and spend a lot of money on analysis or more money on analysis. And then later phase, you're spending a lot more money on material, on we work with contract manufacturers, so working at their sites to do scale up, and then maybe it doesn't work and you just have to throw all that out. So there's a lot more like capital like that's required for doing those processes, and you will do analysis on it too, but the emphasis is more on getting your process right and figuring out how to improve that. And then like, sometimes you need the analyses there, and then you don't. It depends on what you're doing, but I would say really it's like being able to scale up is going to have just a different, like you're going to spend money on different things than you would the early phase.
You're moving from discovery to fleshing out practical aspects of production. I think they mentioned that earlier today, maybe not as exciting, but this is more important.
I
if you're-
like it, honestly. There's just different challenges. It's new problems to solve.
I
Well,
think
I-
it's exciting to be able to make something once or twice. I think if you scale that up and you want to make tons, tens of tons, hundreds of tons of material, it's certainly not boring. The challenges are very different. It's switching from a scientific mindset to an engineering mindset. So the ability to be able to make something reliably, repeatably, the right quality, and to make it at a cost that people are willing to pay for it is, in terms of the absolute spend to take a new material to market, that's more than 90% of the spend. So if you just look about the lifetime of that material, the creativity and the spark of genius to create it is the front end of this. And quite often when we're working with startup companies, I think the challenge we have is the understanding that the amount of capital and effort to take it from, I've got an idea and I've validated it, to having a plant that actually produces quantities of material that when I want it, I can turn it on and make it. That's where the biggest engineering challenge comes.
I've heard that in production, you solve 15 problems in a week instead of one problem in 15 years.
Right. So maybe there's a bit of a misconception that science is where the creativity is, but actually there's as much, if not more, creativity in the engineering to be able to make things at scale, I think.
A lot of creativity and discovery incrementally to solve the
Yeah.
practical
But
problems.
if you don't have a manufacturing process for a material, you don't have a material. And we shouldn't forget that. That is the challenge for a commercial organization, is to take that idea and turn it into something tangible that might be bits of metal and piping and buildings. That's what a business becomes eventually. And that takes creativity and in some occasions genius to make that work as well.
Excellent. Yes.
So I think, I really thought that Jennifer hit the nail on the head during the earlier session about, just having a lab space, having places, if you buy reagents, if you get an SBIR or something like that, you've got to start on day one. Got to start getting those pieces together, even buying a chemical, where are you going to have it shipped? Who's going to manage it and all that kind of stuff. But NanoSafe was a little bit of a different beast. We didn't make a material. We were selling information. So where we started, Lab Conco, which is, you probably worked in their lab enclosures, came to us and they wanted to know if it would contain a nano aerosol, if it was generated inside it. And so that was a loaded question. Just the process of generating a reproducible nano aerosol was a challenge. After that, where we really started zeroing in on what could be a scalable business was, how do you share that information? So they've done this great test, but how do you share that? How do other people find out about what they did? They didn't comply with any government regulation. We couldn't say it was safe. We had to find a communication strategy that was somewhere in the middle. And so I would work on, I was actually trying to find digital, I was creating websites. I was trying to connect information sharing resources so I could capture the information of the people who were needing that information. So we would have folks from major companies come in and download reports about, how did this Lab Conco hood perform with a nano aerosol? And then we would scale that, offer that. Once you have one competitor, or once you have one company in there, their top competitor becomes interested in it as well, because, some of these businesses deal on, who is more rigorously testing their products and that sort of thing. It's from there, the idea was to scale it to other areas. And what we ended up finding, just to sort of close the loop on that, was a lot of companies wanted the information privately. They wanted you to test it, let them know what was going on, share that with them, and that would be the end of it. But I never had the joy of scaling like you folks have, I can only imagine. Where just a bad run, you've got to dispose of a bunch of material now.
Yeah, so a great idea, and then marketing becomes important, and customer service, unique customer service is what I'm hearing. Yeah. Okay, so the future of nanotechnology panel talked quite a bit about commercialization. So let's take the converse of that, and let me ask you guys, what are the developments on the horizon in your respective fields where you expect nanotechnology to have a significant impact as reflected in new nano products or services coming online? So the future of nanotechnology from the commercial perspective.
Well,
Let's go with David.
go with
Yeah,
that one first. So our plan focuses on 2 or 3 key market areas at the moment. So obviously there's an enormous amount of investment going in the battery and energy storage space. So that's consuming on a global level, probably 50% of the consumption of carbon nanotubes today. Very little of that volume is produced in the US today. Most of it's coming out of Korea and China. So that's very much a focus area for us, is how do we develop carbon nanotubes that can be used in the cathodes, anodes, and the current collectors of various battery technologies to be able to aid capacity, to aid charge speeds and safety. There's a really big opportunity because I think nobody's particularly satisfied with lithium-ion technology today. There are other developments out there, all of which I think need improvement in the material science, and carbon nanotubes have got a role to play there. So that's an immediate 0 to 5 year need. I think if I look at the business I mentioned earlier on, where we're looking at low carbon footprint materials, if we want to be able to scale up to produce large amounts of hydrogen, we're going to have a lot of carbon on our hands. And if you say, what are the markets that consume the most carbon today, they tend to be in the area around construction materials. So using carbon nanomaterials as an additive into concrete, for instance, can have some pretty impressive impact on something like compressive strength. What does that mean? Well, I can build taller buildings with kind of reduced amount of material to do it. Or I can make road surfaces which are far less abrasive, protect the lifetime of tires, and need less repair over the lifetime of the road surface. You've got some challenges around construction materials as they're very heavily regulated. So you need to do some convincing of regulators in DOT and other areas that this is the right technology to go. But in terms of mass production of nanomaterials, there really are focus areas. I think the final one I would mention is in the area of more the high performance materials. There's carbon nanotube yarns are a product that we're developing and scaling up. Now, they've got great properties around the mechanical properties. They're very flexible in comparison to things like carbon fiber, but they also have some real benefits in electrical conductivity and thermal conductivity. So a real focus for those products to get into the composites market. There's a lot of opportunities in there. Carbon fiber isn't going to be replaced by these materials, but it's an adjacent material which will make a real difference in terms of lightweighting performance, probably initially in aerospace and space platforms, but gradually moving down towards other applications like the automotive industry.
So it's a smart integration of byproducts from other processes. And I have to ask, David, are you going to store the hydrogen on a nanostructured lattice?
I would love to do that.
Okay.
I think one of our close collaborators is looking at using those nanotube yarns for hydrogen storage.
Fantastic. All right, Matt, what's the future of maybe environmental nanochemistry?
This is like a plant question, and Brandon and Quinn are going to love this. I mean, nano for Earth. Have you guys been waiting on me to say that? Because so last year, the NNCO helped organize the Nano for Earth initiative that was really focused. The 4 was the number 4, And I was joking with someone in the break that it should be Nano 3 Earth now because we are now a year beyond Nano 4 Earth. And the idea there was really focused on translating technologies for mitigating climate change, nano-enabled technologies for mitigating climate change within 4 years. And I think that that's, I don't know, if you're an entrepreneur, if you're in translational activities, you sort of feel an urgency. I think as an environmental scientist, I feel an urgency toward the planet. So I think that urgency sort of combines to, we need to do something about that. And it sounds like David is working on that. So it was a nice lead into that plug. The other thing I would say goes back to what we heard in the earlier panel. It's not so much what we're doing, but how we're doing. I think Doyle said with, who we're doing things with. When you look at entrepreneurship, it's still very much a white male dominated area. Most, when I talk with groups about entrepreneurship and commercialization, I'd say most entrepreneurs look like me, probably a disproportionately large number. And the reason for that is often it relates to your socioeconomic status, your ability to take on risk, maybe to take on debt and weather that and proceed. So I think it's important that the diversification of commercialization is made a priority. So it's accessible to many other folks.
So the future is sustainment
I'd say.
from your perspective. Great. So let's talk a little bit about the workforce. The CHIPS and Science Act has brought the STEM workforce to the forefront of many national discussions. So, as representatives of companies who rely on a skilled workforce, what do you see as the needed skills or experiences in a multidisciplinary nanoscientist, emerging onto the scene?
Well, I can start. So nanoscience is something that we have, or I should say, nanotechnology is something that we have in our product. However, we need people to be trained in more than just that. Like, for example, I mentioned that we're, been done a lot with scale up, and that's, chemical engineering. So if you know about nano, that's really helpful. But if you also know about process engineering and scale up, that's also helpful. So there's kind of having multiple backgrounds which you get trained with multiple things in your, undergraduate and graduate degrees, of course. But I see some of those things as complementary, you can obviously be experts in both.
Yeah. So the traditional education that the workforce has is of value because they attack different problems once you're into the nano production or scale up. Of course, a chemie can do anything. David.
I don't think there's any issue in acquiring kind of talent that's got the right skill sets. I think the issue is the amount of time it takes to get there. There's a limited pool of chemists, physicists, and material scientists to draw on, and to try and go through the process of finding the right candidates with the right technical skill sets, as well as the ability to demonstrate leadership and desire, ambition, willingness to take a risk. If you put all of that together, it can take a long time to find the right candidates, and that tends to be the biggest barrier. We'll certainly say there are shortages in terms of the number of engineers. I think Terry mentioned process engineering, chemical engineering. All of these processes require that engineering skill. We could do with more availability of talent in that area to be able to hire more quickly, because typically that's one of the bottlenecks in being able to scale up, is finding the right team to put onto that project at the right
Do you
time.
use a third party to help find talent?
We'll take any talent from anywhere. Third parties, LinkedIn, you name it, we'll use it.
I was going to say, once Indeed masters AI, they could probably
Yep.
find exactly
And if
what you
anyone
need.
wants to look me up on LinkedIn, if you're looking for something, I'd be very happy to respond.
So Matt, what do the young people need? What are what skills do they need?
I think my fellow panelists have listed a great number of things there. The one thing I would add is emotional intelligence. I think the ability to craft an email or have a phone call where really where you're not creating headaches for your supervisor, or you're it's a challenge. And the best employees I've ever had were ones who really understood how to communicate with a customer. And
Without emojis, right?
well, I mean, if they do it well, I mean, it
Okay,
can work.
okay.
So, yeah.
So we're very short on time. Quinn, do we have any interesting questions?
Well, I think we covered what was in here because there were questions about workforce. So I'm glad we're ending on that question. Because I think that was something, again, that came up from our audience. So I think you're good, Jim.
All right, well, thank you very much, and especially Matt for standing in at the last minute. Let's give our panelists another hand.